Cadmus. Cadmus is a project of the Rexus BEXUS Programme. We are 5 engineering students studying engineering physics, aerospace and telecommunications engineering, and mathematics at UPC, the Polytechnic University of Catalonia, in Barcelona. Yeah, Barcelona, the hot city with nice beaches, the Sagrada Familia and paellas. Oh, and Messi. Let's not drift away though. We were selected on a program called Rexus BEXUS, which allows students from universities across Europe to carry out scientific and technological experiments on research, rockets, and balloons. Each year, 2 rockets and 2 balloons are launched, carrying up to 20 experiments designed and built by student teams. To put it briefly, the Rexus BEXUS program is realized under a bilateral agency agreement between the German Aerospace Center and the Swedish National Space Board. The Swedish share of the payload has been made available to students from other European countries through a collaboration with the European Space Agency. Maybe let's not draw any flag for Barcelona. Okay, we participate in the BEXUS program. This means that we will fly an experiment on a stratospheric research balloon that will reach 30 kilometers from the Earth's surface. With our experiment, we want to play with special relativity and particle physics. We basically want to count muons, a subatomic particle, to know how fast they disintegrate, and therefore verify that the time they take to disintegrate, what scientists call half-life, matches the results predicted by relativity theory. Wait, did you say muons? Yeah, they are a very small particle, an elementary particle of the family of the leptons. I know, this sounds very nerdy. Well, they are similar to electrons, with the same charge but 200 times heavier. And just so you know, there are muons going through your body right now. Let's move on. They are created at about 15 kilometers from the Earth's surface due to cosmic rays decay. For the scientists watching, pions get transformed into muons. They are very unstable. This means that if they are at rest, they decay quite fast, actually 200 times faster than the time it takes to blink. However, they move very fast, close to the speed of light, and as Einstein's special relativity predicts, if they move so fast, time goes very slow for them. They have like an inner clock that slows down the faster they go. Therefore, from the Earth's surface, it appears as though they don't decay so fast. I know, it sounds like science fiction, doesn't it? But this is exactly what we want to measure. We want to obtain the exponential curve of disintegration of muons and see that it matches what Einstein theory predicts. So, how are we going to do it? We will place a muon detector on a balloon that will go up to 30 kilometers in the air and count the flux of muons that go through it at each altitude. Knowing their velocity, we'll be able to count how fast they've decayed. How will we detect these weird muons? We're building a cloud chamber. It is a transparent box full of a special alcohol called isopropyl. It has dry ice at the bottom and heaters on the top to make the alcohol supersaturate and create a foggy atmosphere. When a muon goes through the chamber, it leaves a straight white trace. We will take pictures of the cloud chamber during the flight, and we will use an algorithm to count how many muons have gone through the cloud chamber at each altitude. This is basically how we will count the muons and know what is their lifetime. To realize all of this, we need to acquire a lot of material and need to spend quite a lot of money to develop every part of Cadmus. This is why we have looked for sponsors to help us out with this. We couldn't be more thankful to Kronos, who are lending us 2 of their high-speed cameras able to shoot up to 21,000 frames per second. We encourage you to check them out. Go to crontech.ca. In addition, Fundació Selex is helping us with a very significant contribution. Thanks to them, many projects involving science and education are able to take off in our country. Take a look at their amazing work. Moreover, the FIS Center from UPC is also helping us fund the project. They offer the possibility of majoring in a double degree in a highly demanding program. Furthermore, 2 other centers from UPC are also offering economic support. They are ETCTV, the Technical School for Telecommunications Engineering in Barcelona, and ETAC, the Technical School for Aerospace and Telecommunications Engineering in Castelldefels. We need to mention that our university, UPC, has helped us a lot by giving contacts of professors and helping out with the outreach program. However, we still need more funds to carry out our project. This is why we're asking you to give us a hand by going to igg.me/ad/gocadmus and make a small donation. Every little contribution counts. Rewards await you. We depend on you to finish Cadmus. We could not be more thankful to the UPC professors, especially Antonio Pascual and Kim Trollas, for their help and advice, as well as to the Rexus BEXUS organization for their support, and to all of you who will contribute. Cadmus may be a small step for science, but it will be a giant leap for us. May the muons be with you.